Section 3.9 is about curve fitting for polynomial models. Before we get into that, let's do a quick refresher on how to find some roots. So we've got the function, the equation, 4x to the fifth minus 8x to the fourth minus 32x to the third equals 0. Folks, when you see this, I would suggest factoring out a greatest common factor. So looking at the numbers, 4 is the greatest common factor of all the numbers, the 4, the negative 8, and the negative 32. And we can also factor out an x to the third from each of those. Now when we're factoring it out, again, it's kind of like dividing it out. So 4x to the fifth divided by 4x to the third, or factoring it out, we're left with x squared. If we factor out 4x to the third from negative 8x squared, we're left with negative 8x to the fourth, we're left with negative 2x. And then factoring out 4x to the third from negative 32x to the third, we're left with negative 8, just negative 8 equals 0. Folks, we can factor that a little bit more too. We got 4x to the third, x squared, let me write that properly, 4x to the third, x squared minus 2x minus 8. We're able to factor out onto x minus 4 times x plus 2 equals 0. Now, folks, we're going to get 3 zeros from here. The first one, we're going to say, what makes 4x to the third equal to 0? That's just x equals 0. What makes x minus 4 equal to 0? That's x equals 4. And what makes x plus 2 equal to 0? That's x equals negative 2. Now, I'm also going to encourage us to make a table here for our roots. And on the other column, we're going to talk about the multiplicities, just kind of going back to what we did in the previous section. So 0 is one of our roots. We have also 4 and negative 2. Now, the 0 is used 3 different times. If it helps you to visualize 4x to the third as 4 times x times x times x, you can plug it in for any one of those x's. You could plug in 0 for that x, or for that x, or for that x. So we're going to say 0 has a multiplicity of 3. 4 we could only plug in here, so it'll only be 1. And in a negative 2, we only have one place to plug that in. When you're doing this, make sure your multiplicities add up to your degree. So we have a degree of 5. 3 plus 1 also adds up to 5. For our goal for the day, we got 2 goals, really. To determine the degree of a function from a table of values, and then we're also going to use a calculator to create a function that best models the data. We've really done all this before. We're just applying it to new contexts. So, just like we did second differences that were constant in a quadratic, we're going to get third differences for cubics, fourth differences for quadrics, and you can keep on going. You can go fifth differences, sixth differences, seventh differences. We're only going to go to fourth differences potentially right now. So with that in mind, we're asked to use finite differences to determine the degree of the polynomial that best describes this data. Always double check your x values. So our x values should be evenly spaced. So negative 6 to negative 3 to 0 to 3 to 6 to 9, we're adding 3 every time. So to figure out what differences or what model we should use, we're going to look at the differences from one term to the next. Going from negative 9 to positive 16, we're adding 25. Going from negative 16 to positive 26, from positive 16 to positive 26, we're adding 10. From 26 to 41, we're adding 15. That was weird. From 41 to 78, we're adding 37. And from 78 to 151, we're adding 73. Now looking at those, let me shift this a little bit. Looking at those are not constants. So therefore, we're not dealing with a linear graph here. So if at first you don't succeed, try another row. So 25 to 10, we're actually subtracting 15. 10 to this 15 gives us adding 5. 15 to 37 is plus 22. And then 37 to 73 is plus 36. So those also are not constant. If they were, it'd be the second row, which would be a second exponent, which means we're dealing with quadratics. Let's keep going if it didn't work. Going from negative 15 to positive 5, that's plus 20. Going from positive 5 to positive 22, that's plus 17. And going from 22 to 36, that's plus 14. Folks, those are also not constant. So that if they were, it'd be the third row, so we'd be working with a third degree, so it'd be working with cubics. But it's not cubic. So we're going to try again. Going from 20 to 17, we're subtracting 3. From 17 to 14, we're subtracting 3. There we go. Finally, it's constant. So since the fourth row is constant, I'm going to write this off to the left here so it's not covered by my image. So the fourth row is constant, which means it's a degree of 4. Other words, quartic. So however many rows you need to go, that determines what the degree of your function is.